So welcome everybody to this week's problem set, which is problem set number 5, and we'll deal with the topic of candidates and voting. So let us start with exercise number 1. Consider the following model of two-candidate competition with policy-motivated candidates. Voters have quadratic preferences so that the utility obtained by a voter of ideology I from electing candidate J, where candidate J, like candidate is either candidate A or candidate B, is minus in parentheses ij minus I by the power of 2. Yeah, so those types of utilities are mainly kind of used when you want to say that somebody wants to minimize the distance um, according to some metric. And here the metric is basically the ideology. Voters' ideologies are uniformly distributed over the interval 0, 1, so that the fraction of voters with ideology being smaller than I is just I. A candidate will win the election with certainty whenever he has a fraction of voters which is strictly larger than 1/2. He will win the election with a likelihood of 50% if he has the same fraction of voters as his rival. The two candidates have quadratic preferences with true ideologies TA equal to T and TB equal to 1 minus T. And T is some number between 0 and 1. They also get a non-policy related reward to holding office R strictly larger than 0 if they win. Yeah, so think of this as kind of the utility of a politician who is in charge, basically. So apart from being like a politician and doing something related to his ideology, just think of this as utility of being in power. For instance, when candidate A wins the election, given chosen ideologies IA and IB, his utility is given by R minus, in parentheses, T minus IA by the power of 2, while the utility of candidate B is given by minus, in parentheses, 1 minus T minus IA by the power of 2. On the contrary, if candidate B wins the election, his utility is given by R minus, in parentheses, 1 minus T minus 1B by the power of 2, while the utility of candidate A is given by minus, in parentheses, T minus IB by the power of 2. Consider the game in which the two candidates choose ideologies IA and IB, so it's simultaneously, and then voters vote for the candidate whose announced ideology they prefer. Demonstrate that if IA star IB star is in equilibrium with this game, then IA star IB star is equal to 1/2. So basically, what we want to show here is that the only possible equilibrium in this model is given by both candidates choosing ideologies equal to 1/2. So they locate both of the candidates locate themselves on the median voters, on the ideology of the median voter. Okay, so let us then summarize some of the information that we have gotten. So exercise number 1. So let us determine like the utility that each candidate is receiving, depending on whether he is winning or not. So if A wins, if candidate A wins, then the utility of candidate A, given ideologies IA and IB, this is conditional on A winning, is given by, so since A is winning, he's getting the utility of being in charge, being in office, minus the distance of his chosen ideology to his true ideology T. The utility of candidate B, which also depends on the chosen ideologies, is then simply the distance of the true ideology of candidate B, which is 1 minus T, to the chosen ideology by A. So this is IA by the power of 2. Can do the same thing if B wins. So if B wins, then the utility of A conditional on B winning is given by minus T minus IB by the power of 2. The utility of B conditional on B winning is given by R minus 1 minus T minus IB by the power of 2. Okay, so those are the two cases which can happen and the according utilities. So next, let us determine when does a candidate actually win the election. Yeah, so question is, when does a candidate win the election? So let us denote by SA the vote share of A, and by SB the vote share of B. Therefore, A wins with certainty if SA is strictly larger than SB. Sorry, if SA is larger than 1/2. So if the vote share of candidate A is strictly larger than 1/2, then he has more than half of the voters voting for him, and hence he wins with certainty. A wins with 50% chance if SA is equal to SB, and this is equal to 1/2. So if both candidates have the same amount of votes, so the same vote share, then each of them will win with a 50% chance. And then if the last case is A loses with certainty if his vote share is strictly smaller than 1/2. And keep in mind that we assume here implicitly that the candidates, the voters can vote for either of the candidates and they cannot stay absent. So they have to vote for either A or for B, and hence the vote shares of the candidates always adds up to 1. So let us summarize this. Now, the likelihood that candidate A wins is given by the following. So it's 1 if SA is strictly larger than 1/2. And yeah, this case is then obvious, but let us still write it down. It's 0 if SA is smaller than 1/2 and smaller than SB. And it's 1/2 if SA is equal to SB, and this is equal to 1/2. The probability that B wins is given by the following. So we can actually copy this here. Put here again, and then we simply switch kind of the order of the inequalities here. Yeah, because basically it's the mirror situation considered to the situation where we are looking at events where A wins. So B wins with probability 1, so with certainty if his voucher is larger than 1/2, and he loses if his voucher is smaller than 1/2. Okay, so now we determined the probabilities when one of the candidates would win, or when there would be a 50% chance of winning, or when you would lose with certainty. Now let us come to the voters. So let us consider the voters. So a voter with ideology I will vote for candidate A if and only if the following holds. If the utility of voting for candidate A, so this I will denote by VI of A. So this is the utility of a candidate, of a voter with ideology I voting for candidate A, if this is strictly larger than the utility of voting for B, or the utility of B being in charge. And this is equivalent to, now we're just using the utility functions that we were given in the exercise description. So this is minus IA minus E by the power of 2 being strictly larger than minus IB minus I by the power of 2. And this can be written as, so since this is a minus, you want to minimize it. And what you basically have is that you vote for candidate A if your ideology is closer to the chosen ideology of A rather than the chosen ideology of B. And basically you choose for A if the distance, or the here in our case, if the absolute value of the difference between IA and your ideology I is strictly smaller than the distance to the ideology of B. Okay, so this is determining when you're voting for candidate A. So if this holds, then you vote for candidate A. If it's the other way around, you vote for candidate B. And if VIA is equal to VIB, then randomly vote for any candidate with 50% chance. Okay, so this is now determining basically the behavior of the voters depending on the chosen ideologies of the candidates. So now let's really determine which fraction of voters will vote for the candidates. Okay, so given IA and IB, which fraction of voters will actually vote for which candidate? Okay, so now we know the behavior of the voters. And now let's have a look on which kind of mass or fraction of voters is actually going to vote for each of the candidates, because this will be important to determine who is actually winning depending on the chosen ideologies. So first, let us consider the case where the ideology of A, the chosen ideology of A, is strictly smaller than the chosen ideology of B, and it's weakly smaller than 1. So all voters with I weakly smaller than IA vote for A. All voters with I weakly larger than IB, they vote for B. And now what we need to consider is what happens with voters who have ideologies between IA and IB. And then what will basically happen is that, so let's draw a quick picture here. So if you have IA here and IB here, then those voters here, they vote for A. Those voters here, they vote for B. And then you have the middle point here, which is then IA plus IB divided by 2. Okay, this will give you exactly the middle point here, and everybody to the left of this middle point will vote for A, and everybody to the right of this point will vote for B. Yeah, so this is just a quick picture to explain this to you. So then all voters with IA weakly larger or smaller than I, and this being weakly larger than IA plus IB divided by 2, they vote for A, and all voters with IA. Oh, sorry, there's a mistake here. It should be, of course, like this. And IA, oh, sorry, that's wrong. So all voters with IA plus IB divided by 2, this being strictly smaller than I, and this being strictly smaller than IB, they vote for B. And there's the last case, of course, where all voters with I being equal to IA plus IB divided by 2, they randomly vote with 50% probability. Okay, so those individuals vote with 50% probability. So they mix between the candidates with equal probabilities. So let us sum up the information that we have. So the vote shares of the candidates depending on IA and IB, they're given by the following. So SA, the vote share of A, which now I will explicitly define as a function of IA and IB, is equal to the following. So it's IA plus IB divided by 2 if IA is strictly smaller than IB. Okay, so everybody to the left of the middle point between the chosen ideologies of A and B is voting for candidate A. It's 1/2 if IA is equal to IB, and it's 1 minus IA plus IB divided by 2 if IA is strictly larger than IB. Yes, I didn't cover the derivation of why this holds, but this should be quite clear if you use the same logic that I used before on a situation where A has chosen a larger ideological point ideological point than B, because then he will get everybody to the right of this middle point. The same thing for B. So SB is now defined explicitly as a function depending on the ideologies. So it's 1 minus IA plus IB divided by 2 if IA is strictly smaller than IB. It's 1/2 if IB is equal to IA. IA plus IB divided by 2 if IA is strictly larger than IB. And this basically determines now the vote shares of the candidates as functions of their, so the expected vote shares as functions of their chosen ideologies. So now we basically have everything that we need in order to write down the utilities of the candidates. So utilities of candidates depending on the chosen ideologies. So the utility of candidate A, if he has chosen ideology IA and the other candidate has chosen the ideology IB, is equal to the following. So it's the indicator function with the event SA being strictly larger than 1/2, being strictly larger than SB. So the indicator function is 1 when this event here in parentheses is fulfilled. So it's always 1 when the vote share of candidate A is higher than candidate B. In this case, the utility of candidate A is given by his office motivated utility, so R, minus the distance of his true ideological point minus his chosen ideology by the power of 2. Then the next possible event would be the event where both have the same vote share, so SA equal to SB equal to 1/2. In this case, with a likelihood of 1/2, the candidate A will have R minus T minus IA by the power of 2, so the utility that we had above here. And with probability 1/2, you will get the utility if candidate B wins. Okay, so then it's simply T minus IB by the power of 2. Okay, so this is the second possibility. And the third possibility is that candidate A loses. So this is SA being strictly smaller than 1/2, being strictly smaller than SB. And in this case, the utility of candidate A is simply given by T minus IB by the power of 2. Now, this is basically the full utility function for candidate A, depending on the 3 cases. Now let's write down the same thing for candidate B. So the utility of B, depending on the chosen ideologies. Now the first event, as before, is the event if A wins. In this case, the utility of candidate B is simply given by his distance to the ideological point of candidate A, so the chosen ideology of A. Then again, we have the situation where we have equal vote shares. In this case, it's 1/2 times the utility of candidate B winning. So conditional on candidate B winning. So this is then R minus 1 minus T minus IB by the power of 2 plus 1/2 times the utility that we found above here. So the case when candidate A wins, which is then minus 1 minus T minus IA by the power of 2. Finally, we have the case where B wins. So SA being strictly smaller than 1/2, and the vote share of B being strictly larger than 1/2. Then his utility is given by the utility of being in office minus the distance of his true ideology to his chosen ideology IB. Okay, so now we actually have everything prepared such that we can show that the case where both candidates have chosen an ideology of 1/2 is an equilibrium, because in order to show that it is an equilibrium, we need to consider possible deviations from this equilibrium and to show that there are no profitable deviations. Okay, so this is why we need the utility functions, yeah, to test whether there are profitable deviations or not from the equilibrium where both have chosen an ideology of 1/2, 1/2. So now proof that IA star equal to 1/2, IB star equal to 1/2 is an equilibrium. So first, what is the utility if this is indeed the case? So for the candidates. So what is the utility of candidate A if IA star is equal to 1/2 and IB star is equal to 1/2? Then the utility of candidate A is simply given by 1/2 times R minus T minus 1/2 by the power of 2. Okay, so you can simply plug in this into the according case where both have chosen the same ideology, and then you will end up with this expression. The same for B. So the utility of B if both A and B have chosen an ideology of 1/2. This is then given by 1/2 times R minus T minus 1/2 by the power of 2. So now we will consider deviations from this equilibrium, or this proposed equilibrium or candidate equilibrium, and see whether there are profitable deviations or not. So we will focus on deviations by candidate A. So let us start with, so the reason why, it's because every argument which holds for candidate A will also hold for candidate B. So if candidate A deviates from IA star being equal to 1/2, So if he deviates from this point by choosing a lower ideology than 1/2 or a larger ideology than 1/2, then his vote share will always be less than 1/2. So vote share of A will always be less than 1/2. Therefore, A loses with certainty. Okay, and now if he loses with certainty, so if candidate A is choosing a utility which is not 1/2, sorry, an ideology which is not 1/2, so a utility of IA being not equal to 1/2, while IB is still equal to IB star, so it's 1/2. The utility of the candidate A is then simply given by the distance to the chosen ideology of B, so minus T minus 1/2 by the power of 2. Since he can never, so since candidate A can never be in office with, so with probability 0, he will not be in office. So no, with probability 0, he will be in office. He has no utility basically of being in office, so there is no R here, and as a consequence, this utility here is smaller than 1/2 times R minus T minus 1/2 by the power of 2. And this was the exact utility of candidate A if he would stick to the equilibrium or the proposed equilibrium of choosing an ideology equal to 1/2, given that candidate A is behaving in that way. Okay, so what we now showed is that starting from this point where both have an ideology of 1/2 or choose an ideology of 1/2, A has no incentive to deviate, neither by choosing an ideology lower nor by choosing an ideology higher than 1/2. Okay, so A does not have an incentive to deviate. Same holds for B, yeah, because it's symmetric. And as a consequence, IA star equal to IB star equal to 1/2 is an equilibrium. So next, what we will do is now we showed that it's an equilibrium, but keep in mind that the question was to show that if something is an equilibrium, then it is IA star being equal to IB star equal to 1/2. So what I will do next is I will show you that this equilibrium where both have chosen an ideology of 1/2 is the unique equilibrium of the game. And I will do this by showing you that any other choice of ideologies, so if you fix any other choice of ideologies, then this will lead to a convergence to I star, which, so we will denote I star, this is again notation, I star is equal to IA star, IB star. So the equilibrium that I showed you before. So I will fix any, so I will go to different cases. Actually, I will cover one case where I show you that for this case, what will happen is that starting from the case where we have some equilibrium I prime, which is not equal to I star, each of the candidates will then have a profitable deviation, which will lead them to end up in this I star equilibrium. Okay, so suppose there exists some I prime equal to, and this is another equilibrium or a ideology profile. Let's call it ideology profile. IA prime, IB prime, which is unequal to 1/2, 1/2. Because it's not equal to the equilibrium. Without loss of generality, assume that IA prime is strictly smaller than 1/2 and IB prime is also smaller than 1/2. Okay, so this is again without loss of generality because all the other cases follow from similar arguments. So if now IA prime is strictly smaller than T, so this is the true ideology of candidate A, then there always exists, or candidate B has a profitable deviation by choosing IB prime, IB, so we're now considering deviations, IB equal to 1 minus T. So if we start from an ideology profile where both candidates have an ideology, choose an ideology which is less than 1/2, and in addition, if now IA prime is strictly smaller than T, so the chosen ideology of candidate A is strictly smaller than his chosen ideology, than his true ideology, then candidate B has a profitable, it's actually the best profitable deviation, and it's given by choosing his true ideology. So why? So in this case, B wins with certainty. Okay, and he wins with certainty because as long as IA prime of T, IA prime is smaller than T, so don't forget that T and 1 minus T is symmetric. So if A is somewhere here, okay, let's say this is IA prime, this is what you will get. And if B then goes to this point here, then what he will get is he will get this part and the middle point between IA prime and IB, which is somewhere here. And in sum, his part will always be strictly larger than a part of A. And the consequence of this is that B wins, and not only does B win, but he wins by having chosen his true ideology. So he's minimizing the distance between his true ideology and the chosen ideology of him. So let us write this down. So he wins with certainty since the following holds. So SB of IA being equal to IA prime and IB being equal to 1 minus T, given that IA prime is smaller than T, of course, is 1 minus IA prime plus 1 minus T divided by 2. and this is equal to 1/2 minus IA prime minus t divided by 2. And since this term here is strictly negative because t is larger than IA prime, this term here will be strictly positive, and hence the whole term is strictly larger than 1/2. Okay, so B wins with certainty because of this, the argument that I showed you here, and he minimizes his distance. The distance to his true ideological point. His utility is now given by R, yeah, because he minimized the distance to his true ideology, and he is winning with certainty. Hence, he will get the office motivated utility, and the utility of A is then simply minus t minus 1 minus t by the power of 2. And this is equal to minus 1 minus 2t by the power of 2. Okay, so starting from the strategy profile here, where IA prime was smaller than t, I now showed you that candidate B had a profitable deviation. So now starting from this point where B deviated, I will show you that also I has an incentive to deviate. Okay, so now given IA being equal to IA prime smaller than t, and IB being equal to 1 minus t, candidate A can profitably deviate to IA being equal to t. So if B has chosen his ideology and A has chosen an ideology less than his true ideology, then A can profitably deviate to his true ideology. By this, so A increases his chance of winning the election to 1/2, so from 0 to 1/2 to be precise. And if he wins, he minimizes the distance to his true ideology. And if he loses, he will end up with the same utility as in the case where he had chosen IA prime and IB, so B had chosen an ideology equal to 1 minus t. So the utility of A is now the following. So now they have both chosen now they have both chosen their ideological points as the chosen ideologies. And the consequence of this is that since the true ideologies are symmetric, the consequence is that the vote shares will be equal to each other. Yeah, so therefore the utility of A is given by 1/2 times R minus 1 minus t by the power of 2 minus, now this is utility if it loses, t minus 1 plus t by the power of 2, and this is equal to 1/2 times R minus 1 minus 2 times t by the power of 2. And the utility of B is 1/2 times R minus 1 minus t by the power of 2 minus 1 minus t minus 1 plus t by the power of 2, and this is equal to 1/2 times R minus 1 minus 2t by the power of 2. Okay, again, since they have chosen symmetric, so ideologies which are symmetric to each other, so the true ideologies, the utilities are the same because the vote shares will also be the same. So what we now showed is that starting from the strategy profile, so the candidate profile, the ideology profile in the beginning, we now end up to a situation where both have chosen their true ideologies. And now comes the paradox thing. Now, even though both have chosen their true ideologies, there will be a convergence to the middle, so to 1/2 to 1/2, to the median voter ideology. And this is what we will now show. From IA equal to t and IB being equal to 1 minus t, the candidates will deviate, which will end up in I star equal to 1/2, 1/2. Okay, so this is now what will basically be the outcome. And the paradox thing here is that if there is a deviation from this ideology profile to this ideology profile, both candidates will be worse off if they end up in this profile here. And the reason is simply because from this profile where both have chosen their true ideology, so in this situation, both of them will win with probability 1/2. And if they win, they will basically they will minimize the distance between, so they will minimize the distance between their chosen ideology and the true ideology in case of winning. In case of losing, it's simply the distance between their true ideology and the ideology of the other candidate. Whereas in the case here, basically in both cases, independent of whether they lose or they don't lose, they will have a deviation from the true ideology. And the probability of winning and losing will be again 1/2 here. Good, so let us show this. So A could deviate to IA being equal to T plus epsilon, and epsilon is just very small, a very small strictly positive number. As a consequence, the vote share of candidate A, so if he's choosing T plus epsilon and B is at 1 minus T, then the vote share of A is T plus epsilon plus 1 minus T divided by 1/2, by 2, and this is equal to 1/2 plus epsilon divided by 2, and obviously this is strictly larger than 1/2. A would win with certainty, and its utility is R minus T minus epsilon by the power of 2, which is then equal to R minus epsilon by the power of 2. The utility of B would be minus 1 minus T minus epsilon by the power of 2, and this is then equal to minus 1 minus 2 times T minus epsilon by the power of 2. So why is this a profitable deviation? Well, the reason is, of course, there is a deviation now in which A is departing from his true ideology, but keep in mind that this epsilon can be as small as you can imagine. So the distance to his choosing ideology and the true ideology can be still arbitrarily small. So the damage here, in case he's winning, can become arbitrarily small, but the probability that he wins is always one independent of how small epsilon is. So by a tiny deviation, slightly above his true ideology, candidate A can win with certainty and still make sure that he does not deviate too much from his true ideology. This is the reason why this is a profitable deviation. Now, given this deviation, what can B do? Now, B can deviate to IB being equal to 1 minus T minus 2 times epsilon. So he can choose the same epsilon as A, independent of how arbitrarily small epsilon is, and then B wins with certainty. And his utility is higher as in the case before. Okay, so now you see that when A is deviating with epsilon to a point above, so he's adding epsilon to his true ideology, and this is his deviation, then B can deviate by choosing a deviation which is 2 times epsilon lower than his ideology. And a consequence, so if you continuing this reasoning, continuation of this reasoning will yield IA IB being equal to I star equal to 1/2, 1/2. And so this is the reasoning why. So they will always get closer and closer to the median voter ideology. And the interesting thing is that this holds even if R is equal to 0. So even though the value of getting elected and having office motivated utility is equal to 0, the candidates will still deviate from their true ideological point, which is basically harming them, and they will converge to the median voter ideological point, which is then 1/2. Okay, this is quite interesting and counterintuitive result. And basically this finishes this exercise. So what we wanted to do is we wanted to show that 1/2, 1/2 is an equilibrium. And we also wanted to show that it's the unique equilibrium. And we did this by showing that at least for one of the special cases, I mean, going through all the cases would take a lot of time. But now the case that I covered here, you can maybe as an exercise for yourself, try out the different cases and show that the same thing holds. So this is basically what we have proven for this case. So we showed that if you start at a ideology profile given by IA prime being smaller than 1/2 and IB prime being smaller than 1/2, we will always end up in the equilibrium that I derived in the first place, where both would locate themselves at the median voter ideology.